Welcome back to Boring Math Tutor. Got ourselves some sort of parabola thing here. This equation is 4 minus x squared. And it looks like there's some sort of shaded region here. And that's just indicating that that is going to get swung around the line x equals 3. So x equals 3, that's right here. And they're going to rotate that region around x equals 3. And you can kind of barely see that the textbook has a little dotted line going over here to indicate that that's the same thing as that shaded region. So ultimately what we're going to end up with is something that might look like one of those weird Italian cakes. But yeah, we're going to end up with some sort of 3D shape, but there's going to be a gap in it. And we have to figure out what the volume of this is. Well, the way to get this guy done is the washer method. And the washer method requires you to find an inner radius and an outer radius. And they were actually so nice to us that they told us what the inner radius is. And an inner radius connects from the line that you're rotating around until the edge of the rectangle that you're using as a sample slice of the region that's getting rotated around. So here's a sample slice, and if you're using the washer method, you always want to be having a rectangle that is perpendicular to the axis that you're going around, and that is happening here. So we're good. But yeah, anyway, we've got our inner radius. But when you do the washer method, you always need an outer radius as well. And I like to do a capital R for my outer radius and a lowercase r for my inner radius. And then when I write down the volume using the washer method, I write down pi times the integral of capital R squared minus lowercase r squared. So capital R squared in this case is always going to be 3. So where I see this capital R, I'm just going to put a 3. And the inner radius, well, I would get that by subtracting x coordinates. So I would need the x coordinate over here, which is 3. And I need the x coordinate over here, which, well, they already gave it to me. It is x. So it's going to be 3 minus x. So when you subtract 3 and x, that'll get you the length of your inner radius. And now we just need to set some boundaries for where this is happening. Excuse me. Before we get those boundaries in place, we need to first put down what the thickness of that rectangle is. Now, in this case, our rectangle is going to be from here to here. That's going to be a dy. So we're going to end this integral with a dy. And the dy tells you that your boundaries are going to need to be in terms of y. And I can see here the smallest y would be 0, and the biggest y would be 4. Now, next step is to recognize that I've got an x in here, but I've got a dy. When it's a dy, you got to get everything in terms of y. You can't have an x. So the next step is to take this equation, y equals 4 minus x squared, and solve it for x. So that'd be x squared equals 4 minus y. And then x would equal plus or minus the square root of 4 minus y. But in this case, if you're looking at the graph of that original thing right here, it is a graph of positive x values. So we actually only care about the positive, so we don't need the plus or minus. We can just simply put the square root. Okay, so that goes in right over there. So it's now going to be 3 minus square root of 4 minus y, blah, blah, blah. Square that all up. And 3 squared is 9. Integral from 0 to 4, blah, blah, blah. And now we just got to play around with some algebra stuff. This one is going to end up being 9 minus 6, blah, 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 plus 4 minus y. It's going to be a minus sign out there. Distribute the minus sign. 9s will cancel. You'll get 6 root plus blah, blah, blah. And then we got to rewrite this as 6 times 4 minus y to the 1/2. And I'm going to set up the integral on that one. Whereas the other ones, I can just easily do the integral right now. So it's going to be 4y minus y squared over 2. Okay, but now I just need to complete this guy right here. So it's going to be 6. And then it's going to be 4 minus y to the 3/2. But then all of that is going to be over 3/2. But then it's kind of like the chain rule where I need the derivative of the inside. And the derivative of the inside is -1. And I always need to divide by whatever that is. Now, that would be the same thing as just putting a -1 in the bottom, though. If you wanted to do a u substitution for that, you would end up getting the same answer. But this is a nice little shortcut. So anyway, you end up getting 6 times -2/3 4 minus y to the 3/2 plus 4y minus y squared over 2. We're evaluating all that from 0 to 4. And I'm going to leave that calculation for you to finish. But I really hope you subscribe. Otherwise, I'm just going to quit YouTube.